Hello and welcome to this introductory presentation of Keraring AS, progressive thickness intrastromal corneal ring segments manufactured by Mediphacos. In order to better understand the principal mechanisms of action of Keraring AS, we will first review some of the mechanisms of action which are common for all intracorneal ring segments. This type of implants works according to the so-called Barraquer corneal thickness law, which states that to correct myopia, we can either remove tissue from the central cornea or we can add tissue to the periphery of the cornea. Thus, intrastromal corneal ring segments can flatten the cornea or correct myopia by adding tissue to the periphery, the tissue added being the implant itself. Conversely, for hyperopia correction, we can either add tissue to the center or remove tissue from the periphery of the cornea. In the 1960s in Russia, Blavatskaya proposed the first nomogram used for refractive correction by means of implanting a ring-like implant made of frozen corneal tissue. Blavatskaya's experiment was very interesting because she determined that by reducing an optical zone or increasing the implant thickness, we achieve greater effect. So basically, we achieve more effect with less diameter, and we also achieve more effect with more implant thickness. The Keraring AS has a 5 mm optical zone, 160 degrees arc length, a 600 micron width base. It has the triangular prismatic cross-sectional design, which is classic of the Keraring. It has progressive thickness in the same segment, so the thickness ranges from 150 to 250 or 200 to 300 microns in the same segment. The direction of the thickness increase can be either clockwise or counterclockwise, and if you look at the implant design, you can see that the tips has a configuration of an arrow-like shape, and the arrow indicates the direction of the thickness increase. For example, this is a Keraring AS whose thickness is varying from 200 to 300 microns in a clockwise direction. Conversely, this is also a 200 to 300 thickness Keraring AS, but in which the increase of thickness takes place in the counterclockwise direction. The Keraring AS progressive thickness profile produces a progressive flattening effect, so it allows better customization of the corneal remodeling according to the needs of each individual case. So the implant effect increases progressively with the implant thickness. Surgical planning for Keraring AS employs a similar procedure as the one used for the standard Keraring. The Mediphacos nomogram suggests classification of the keratoconus according to the degree of corneal asymmetry in relation to a reference meridian. The reference meridian can be either the topographic or refractive steep meridian or the coma axis, depending on the treatment strategy. On the left, we can see a type 1 case in which 100% of the ectatic area presents itself on one side of the reference meridian. On type 2, we have a distribution of about 20–80%, whereas on type 3, the ectatic area distribution is roughly 40–60%. And finally, on type 4, we have an equal distribution of the corneal stiffening on both sides of the reference meridian. Each type of keratoconus has its own dedicated nomogram. Basically, the more asymmetric distribution of the ectatic area, the more asymmetric the implantation shall be. And today we can have a variety of arc lengths and thickness in order to address each individual case. For example, this is a type 1 case in which 100% of the ectatic area is located on one side of the reference meridian. According to the Keraring nomogram, in cases like this, the treatment would be based on either just one inferior temporal ring segment, normally of 160 degrees arc length, and in select cases of very high astigmatism, there's a possibility for a second segment on the opposite side, but with less arc and thickness, as to assist in the correction of high cylinder. Conversely, in cases where we see a more symmetric distribution of the ectatic area, we will also use a symmetric implant strategy by implanting two ring segments of same thickness and arc length. Let's see some real case examples of how to assess indication for Keraring AS. Here we have a left eye presenting with an inferior temporal oval cone, a fairly common type of keratoconus in the corneal practice. Here we have a steep meridian located at 50 degrees, which gives us a type 1 or 100% of the ectatic area on one side. As mentioned, these cases would normally receive either one ring segment on the inferior temporal side or perhaps a second segment or shorter arc and length on the opposite side to help with astigmatic correction. However, if we take a closer look at this corneal curvature map around a 5 mm optical zone, we can see that at 3 o'clock the corneal curvature is about 55 diopters, but at 6 o'clock the curvature is much higher, around 61 diopters. This is a typical case that is indicated for Keraring AS. We would therefore implant one inferior temporal segment with a clockwise thickness increase as to have more effect inferiorly where the cornea is steeper and less effect temporally where the cornea is not as steep. Yet another example. Here we can see an asymmetric bow-type cone with a steep meridian at 90 degrees and a rather symmetric distribution of the ectatic area. As we saw earlier, the classic conduct in cases like this is the implantation of two segments of same thickness and arc length. However, a closer look at this curvature map reveals that the cornea is much steeper inferiorly than superiorly. Here, again, we see good indication for Keraring AS by using segments of greater thickness inferiorly and less thickness superiorly. Keraring AS may be used in all cases in which corneal curvature symmetry is observed within the implantation zone. Let's look at some of the keratoconus phenotypes more commonly indicated for Keraring AS. On the left, we have an asymmetric bow-type pattern. On the center, we have an oval pattern, and on the left, we see a decentered cone or pellucid-like pattern. All of these keratoconus phenotypes may benefit from Keraring AS. We will select the correct implant size and direction of thickness increase as to have greater implant thickness or additional effect where the cornea is steeper. The Keraring AS has the same indication and contraindication criteria of the classic Keraring. It is implanted using the same surgical technique, be it manual or femtosecond laser assisted, so there is no new learning curve involved, and it allows greater customization of corneal remodeling according to the needs of each individual patient. We expect, therefore, to achieve improved visual and refractive results with implantation of Keraring AS. Thank you very much for your attention, and I hope you will consider Keraring AS on your next cases.